Thank you very much for coming back. Not that we expected otherwise, but welcome back into the room. So we continue our round of lessons learned. Thank you. We continue our round of lessons learned with the French U-space experience. Please join me in welcoming Mr. Richard Beaulieu, UTM U-space Program Manager at Thales, and Ms. Marie Verdurme, Product Owner at Innov-ATM. Welcome.
Thank you. So I want to thank all of you to attend. We are at the end, not at the end of the afternoon, but just after this coffee break. So I hope you enjoy it. Cheng is not here for the moment, but he asked us to put in our presentation a demo, video, and presentation. We tried to do all of that in one presentation. I hope it will go smooth, as you know. Okay. Come on, so the agenda will be a general presentation of the French cluster. After that, you will have the demo of the flight authorization, not so long, but just to give you a flavor of what we are able to do. After, a focus on the tracking, which is one of the most important parts we have developed in our French cluster, and a conclusion. First of all, I think we need really to focus that we have, through our cluster, focus on the technical part. As you can see here on the first slide, it is the French cluster, it is from Thales and Innov-ATM, it is two industrial partners and not an NSP. We have a second cycle where we have Eurocontrol, not only because they lead this project, but also because we have done some campaign with them, and you will see that later on we will use also some infrastructure. And of course, we will have systematic, which is the authority of the area we are. Another circle, and this circle is very, very important, is all the drone operator who use our system and will be part of this cluster. They were not funded by the project, and so it is important to know that we have also built a very vibrant community to be sure that we will be able to test and to deliver what we have. And we have also the DSAC, and you will see just after DSAC, so it is a French authority, and you will see that in a few moments. So what is a French cluster? French cluster is, I can say, 3 dimensions. One dimension is the operational site itself. The second dimension is the technical dimensions, and the third one is about the demonstration and the tests we have done. For the operational part, we have this site location, so what we call the up drone. So it's a test site, very well known in France, where you have this LFR 333 with more than 300 hectares where you can fly with a drone. And if you have some tests to perform, I encourage to contact Systematic, or you can contact me, and I will introduce you to this up drone and this test site. For that, we have also a runway and a very beautiful building to supervise and to work in. This building, where you have a lot of SME and startup in the drone community, on which was part of this our French cluster. What we have done also in the context of U-ELCOME is to create a corridor which is 20 kilometers long, which is able to be activated by NOTAM. through the authority, so by a systematic. So here you have also reference of this corridor. You can see that you can have some return part on the path. So all of that is available, and it is not the end of this project, which will end this corridor. So all of that have been built during the project and will remain at the end of the project. Okay. As I said before, the first part is the operational side, the site part, and the second part is the technical side. So here you have an overview of our architecture, where we have all the drone operator, and I want to thank them again, even if none of them are here, for their participation in our system, because it was very useful. In particular for Parrot, for example, we have done some tests with them to be able to connect their GCS to our system. About the services, as you can see, the operator services. So we have done an integration of 3 different operator services. So the Drone Keeper one, we will demonstrate that just after. The Scaflight one, so the Scaflight one is a support for my colleague of US 100, where they have developed a complete system to support BVLOS operation, and the Astra UTM part, which is the operator side. So the operator side, you will see just after we have a web portal, but if needed, and we can discuss that during the exhibition later on, we can have a kind of a mobile app also to send any flight request. On the authority services, to support the authority, so we have a U-space part, which is managed by InnovATM as a certified USSP. And we have more on authority, a physical one, I can say, by Systematic. And both of them are supported by one system, and you will see how all of that interact. And of course, we have some tracking services, and I will go into the detail later on. Now, I will move to the flight authorization part. Mary will explain that to you.
Thank you, Richard. Good afternoon, everyone. So to illustrate the connection between the different platforms that are part of the French cluster, we'll conduct a flight authorization demonstration. So before actually starting the demonstration, let's have a look at the zones of interest for our demonstration. So in red here, this is the hub drone zones that is represented, which is managed by Systematic Authority. The dotted blue line represents the test U-space that we have created for the purpose of this demonstration, and which is managed by InnovATM as a certified USSP. And finally, we have the 3 blue zones, which represent the flight zones where our operator wants to operate. Okay, so our demonstration will be divided into 4 steps. So the first steps will be submitting requests for flight zones 1 and 2 from Drone Keeper operator portal to Systematic Authority. Then the second step will consist in submitting a request for flight zone 3 from Top Sky Astra UTM operator service to Systematic Authority. Then in step 3, we will go to Top Sky Astra UTM Authority platform in order to approve the requests made for flight zones 1, 2, and 3. And finally, we will go back to Drone Keeper platform, where we will submit a request to the U-space. So we can now switch to the demo. So this is Drone Keeper portal. So on this portal, we have already created a mission with flight zones 1 and 2. We have also specified a flight period as well as operation criteria. So is it in line of sight or beyond line of sight in populated area or not? And so based on those three information, the platform is capable of listing the constraint and procedure that the operator will have to comply with in order to fulfill his operation in line with the local regulation. So in our example, he will have three different procedures to go through, but as part of this demonstration, we will only focus on the first, which is the request to systematic, and the third one, which is the request to the U-space. So starting with the systematic requests, so our operator will be able to very easily submit his request directly from this operator portal, because as part of U-ELCOME project, we've implemented the interoperability between DroneKeeper and Top Sky Astra UTM platform, which is the platform used by Systematic to manage their requests. So to do it, we just have to click on this button, select one of our flight zones. So let's start with flight zone 1. The form that opens is mainly already filled with the mission information as well as the operator profile information. We just have to fill the last empty fields and submit the request. Then we will just repeat the same operation for flight zone 2. So again, I'm filling the last empty fields and submit this second request. And so now I hand over to Richard, who will talk about the Top Sky Astra UTM platform.
So yes, we move to this Astra UTM platform. So for the moment, I am on the operator side, the web portal. So as I said, you can have the same on the mobile app. And I will send a request. Okay, so here I just more or less feeling the same kind. Okay, until sometimes it's better with the mouse, but okay. So here, brief description is a test. And here we have to fill in the activity purpose, so demonstration. I will be in open operation, so directly it is a VLOS operation. I will say I will do during the light. Here I am connected as a manager, so I am able not only to manage my flight, but also if I have a commercial organization and many different pilots, I can use different pilots. Okay, so I use this one. And link, okay, as usual. Okay, so I will remove that. Okay, and link, now I go to the specific one, and I have access to different drones, and I could use one of them. Okay. Okay. So, and now I have to put, of course, my operation. So just if you can see, it's if you can read French, it's a Bois de Beaulieu, so it's more or less a Beaulieu forest. Just it's my name. Okay, just. Sorry. Okay, and now I send to validate. Okay, sorry for that. I put not the right end time. So you can see that it is, you have some check before you can send. Okay, so here I have my new request into my dashboard, and now I can move to the authority part, where here I have all the authority of the up drone, so the LFR 333 and the corridor, and I just have to move. Sorry, I'm not very good at that. And for each of these flight requests, so the drone keeper one, I can approve it. Yes. For the sake of the demonstration, the authority as a systematic don't have to validate if there is some overlap between the different missions. You will see that during the USSP part, it is the deconfliction is done by the USSP. The authority is, for the sake of this demonstration, is only in charge of approving the different criteria you can have. So here, it's just me. And I can also approve this one. Okay? So now we are at a state where the authority as systematic has approved all this mission, and we will come back now to the operator side where we are into the U-space done by Innovatium.
Yes, so back to Drone Keeper Operator Portal now, where we can see that we obtained the authorization from Systematic for the 2 flight requests we made previously. So now we can focus on the authorization request to the U-space. So just like for systematic requests, this can be done very easily from Drone Keeper web portal, because there is an interoperability that has been developed between this operator portal and the platform that managed the authorization for the USSP. But unlike the systematic authorization process, here the process is in 3 steps. So the first steps consist for the operator in introducing himself as well as the main characteristic of his operation to the USSP. So in order to make the demo a bit shorter, this first request has already been submitted and accepted. But then the second step, once this first introduction has been accepted, the second step is called the flight request, and consists in specifying exactly where and when the flight will take place. So to do that, we just have to click on Ask a Flight Authorization. Once again, the form is pre-filled with the mission information. So we have selected Flight Zone 1 here. We select also the aircraft with which we want to perform the flight, and we submit the request. So those requests are automatically processed in order to avoid strategic conflicts. So here I don't understand why it has been rejected, so maybe I will just move to a backup video. Yes, so basically, sorry for the inconvenience. So basically, yes, we were here, so submitting a request for Flight Zone 1. So as I was saying, these requests are automatically processed in order to avoid strategic conflicts. But first of all, our operator has to confirm that he got the necessary authorization from Systematic to fly in this area, as systematic authority zones overlap of our U-space. But once he has confirmed this authorization, the request has been automatically accepted. But if we reproduce this operation for Flight Zone 2, this time on the same period, so here again we select the aircraft and submit the request. Again, we have to confirm that we got the necessary authorization from Systematic. And once it is confirmed, the request is automatically rejected because it conflicts with another approved request in this same U-space, so it conflicts in both location and time. So once those two requests has been accepted, so the first request that consists in introducing the operator, and the second request, which is the flight request, so specifying exactly where and when the operator wants to fly. There is a very last request, which consists for our operator in asking for takeoff clearance on the day of flight. So this can be done very easily from this button, Open Traffic Info. And so this leads us to the last part of our presentation, which is about tracking. So we can go back to the slides. Yeah, and can I have the mouse as well, please? Yes. So basically, once our operator has clicked on Open Info Traffic button, he lands on this page, which is designed to be used on a smartphone, as this request for takeoff clearance is obviously made on the field. So once our operator has turned on his drone, and when the present time is within the period of his accepted flight plan, he can ask for activation. And this request is also automatically processed in order to avoid pre-tactical conflicts. So here it's automatically accepted, and so when it's accepted, the interface switch to the traffic information interface, where our operator will be able to monitor his flight. So from this view, he will be able to access many information. So first of all, the information of his own drone. So in light blue here, this is our operator drone. So the point represents its current position, the dotted line represents its history trajectory, and the solid line, the speed vector. And you can see similar information for other aircraft, unmanned or manned aircraft flying in the U-space or in the vicinity of the U-space. And you can also see the main zones of interest, so basically is flight zone, which is represented here in blue, the U-space borders in gray, and any other restricted or prohibited area that are overlapping our U-space, but there is no such zone in this example. So from this interface, our operator will be able to declare an emergency, for example, if he lost control over his drone. So then his drone turns to red in order to highlight the fact that we have an issue on this drone. And he can simply stop the emergency by clicking again on the same button. And then, thanks to the conformance monitoring service that has been developed, we will be able to raise alerts in any dangerous situation that may endanger the safety of the operation. So we'll see two examples of alert that may be raised here in this pre-recorded video. So the first example is what happens if two aircraft are too close from one another. So basically, if the distance between both aircraft is shorter than the minimum safety distance, then again we have an alert which is raised and which disappears as soon as the distance between both aircraft is again greater than the minimum safety distance. And so the last example of alert we will show you today is the deviation alert. So what is happening when the operator deviates horizontally from its flight plan. So this is going to happen in a few seconds. So here we go. Yes, so here again we have an alert, which is this time orange because the danger that this situation represents is less than the two situations we've previously presented. And so this ends this demo of the information traffic interface, and I now leave the floor to Richard, who will talk a bit further about tracking.
Yes, because to do that, you need to put in place an infrastructure. So exactly on the top Astra UTM, we have also this kind of services, and we need to feed these services with all this infrastructure. So what we have done in the French cluster is we have done in infrastructure with direct remote identification by putting 2 antennas into the Eurocontrol rooftop, because we are very close to the Eurocontrol premises, is up drone. So they are the antenna we put on, and we connected these antennas to our system. Of course, we have also the remote ID identification, thanks to the remote ID developed by Thales, which is a Skyflight remote ID. When you have that, you can provide all the data, and you are able to have this kind of services. So I just put as an illustration this non-conformance monitoring services. What is also important is also to have all the different archive you can have, and that is also a service we provide to our operator to archive in our system the different flight, and could be independent, and in particular for the authority or the regulator to have an independent archiving of all what you have done. In particular here, it's an extract of our demo day in May. And you can see here the archive from the AVEM, from the Thales, Thales AVS, and it is the first period to go to the corridor. As a conclusion, the first one is we have digitalized all the flight authorization into the systematic. Just for you to know that 3 years ago, they use email, Excel, and all of that. You imagine when you will see the numbers after that, how you do that with this kind of process. And we have technically implemented the drone surveillance. And in particular, I don't want to go into the detail, but the idea is behind the surveillance, you need to have tracking on all of that, what I said just before. So about the numbers, during this period, we have more than 1,600 flight requests. With, you can see here some numbers about pilot drone and US operator we have. As I said from the beginning, we are industrial suppliers, so I think the last word in this case is done to our customers, systematic.
Good morning, everyone. I'm Tamara, the manager of the flight space Richard presented here in Bretigny, France. Since 2023, the hub drones of systematic deep tech cluster has been working with Thales and innovative on the U-space project. Here on the runway, multiple companies helped us try out our ideas for the digital management of the airspace, the 3D segregation of flights, and the cohabitation of simultaneous flight trials in the U-space sandbox. We guided drone users through our platforms, apps, and handed them remote IDs to reinforce the regulation of our trial center. We provided them back with useful data and positioned ourselves as a trusted partner when they had to hand back those data to the authorities supporting their own projects. We have reached now a crucial meeting point between our needs and our competence, and we are eager to develop along Thales under our own convictions. I trust we will keep working on the specifics of the U-ELCOME project after its report, as the flight trial center is such a peculiar airspace to manage.
Okay, so, sorry. So thank you, and so thank you for this, to attend this presentation.
Thank you very much indeed, and you finished right on time, so you'll see there are a couple of questions for you on Slido, so take the time to answer them. For the final session of the day, we'll have the opportunity to hear about the U-space handbook. Ms. Marina Jimenez Navarta, UAS U-space specialist at Eurocontrol, will entertain the discussion between a number of experts involved in the development of the handbook, which was designed as a one-stop shop to share the results of the projects and disseminate their benefits. Please join me in welcoming Marina.
Okay, so good afternoon, everyone. Today, I was given with the very difficult mission of being the last presenter of the day. Also, a very challenging slot of 1 hour and a half. So this is why I won't be alone during my presentation. I will be surrounded by great experts that will provide with very valuable insights about key topics. So I will try to be short with my presentation, and then we will pass to some interesting discussion, and also it will be a session that will be interactive, so also you will have the opportunity to provide your inputs and your opinion in some of the topics. Well, today the journey, as we already seen during the day, has been full of great presentation that show all the result, all the hard work that the companies have been doing during these 3 years in collaboration with the authorities, both the national, local, and the European authorities. All this hard work has been resulted in success stories such as the certification of the USPs and the CISPs, also the interoperability achievement that we just saw before between Spain and Italy, and also some U-space, aerospace designations that are not ready yet, but will be ready shortly, hopefully. So these are a lot of successes that are the result of this collaborative work done by U-ELCOME and also BURDI and ÉALÚ-AER that will be presenting tomorrow. But at the same time, we all know that there are still challenges, things to be done in order to make U-space a reality spread throughout Europe. So in this line, this session is oriented. During this session, we are going to talk about lesson learned. We are going to talk also about challenges and about how the experience of these first implementers, because the first implementers of U-space in Europe are here in this room. So it's important to understand how the experience of these implementers can help the ones that are coming next. And this is exactly what we try to do with this document, with the U-space implementation handbook. Well, as I said during my presentation, I will be just after this presenting shortly this document, and then we will run directly into technical discussion to talk about this lesson learned and about these challenges. We will have these 3 discussions. Of course, there are much more topics that are key topics and are interesting, but we chose these ones. So we hope that you enjoyed them. We will talk about surveillance systems to support U-space. We will talk about e-conspicuity, and we will talk about dynamic aerospace reconfiguration. So going into the details of this document, we can start with, we are going to talk about the U-space implementation handbook, but let's start with what is a handbook. Well, a handbook is a book that contains instruction or advice about how to do something, or contains the most important and useful information about a topic or a subject. And in this line is exactly what is this U-space implementation handbook. In this document, the experience gained within and outside U-ELCOME project is compiled to help future implementers with the experience collected during these projects. This document provide a clear theoretical and regulatory foundation, and also practical knowledge from U-ELCOME project, other DSDs, and also real-life experience. This document is not yet available, but it will be available shortly. It's under revision right now by SESAR joint undertaking, and it will be published in the next week. Well, before continuing, I would like also to highlight what is not this U-space implementation handbook. I want to make it clear because I don't want to bring anyone to any confusion. This U-space implementation handbook is not, in any case, is a maxim, is not intended to replace any regulatory document, is just a support with our experience, and is not either a formal description of any SESAR solution. It's just a combination of experiences from different SESAR solutions with the only objective of implementing U-space. Going into the details about how this document was built, this has been a process of many months, many iterative cycles where we fly, we learn, we collected lesson learned and recommendation, we discuss both with the other DSDs, BURDI and ÉALÚ-AER, but also with other stakeholders that were invited to the workshop that we organized during these 3 years, and where we had the opportunity to discuss, to have the input from them, to know their opinion about what they think about this document, and also what they think about this lesson learned that we collected during these years. So this has been a completely iterative process. We have changed, we have collected, we have changed, we have discussed, and all this process has been led by the Work Package 4 of U-ELCOME, of course with the input of other stakeholders, but I would like to highlight the work done by the Work Package 4 because it was a hard work to collect and to coordinate all the inputs from the big project, U-ELCOME, 3 clusters, different input, different technologies, different experiences, and try to collect everything, and also to collect the input from the other projects was not easy. It was not easy, but we did it, and we are quite proud about what we collected in this document. So going more into detail about what is the content of this document. When we started this project, we had completely a blank page about this document because it's not like other SESAR document that you have a template and you have to be worried about the results, but not worry about the structure of the document. But with this document, we were completely blank from scratch, so we had to decide about what is the structure, what is the content that I would like to read in a document called like this, U-space Implementation Handbook. So for that, we decided to divide the document in 2 parts. One part that is setting and providing theoretical and regulatory framework. Currently, we have a regulation in place, we have a standard, we have AMC, GMs. So the idea is taking all these regulatory documents, all these published documents that are the foundation of the U-space implementation, take all of them and try to put everything in order, in a timeline, and try to describe what is the process of implementing U-space. Here we talk about regulation, standards, we talk about what is the process that you should do to implement U-space, we talk about certification, we talk about what are the requirements that the operators, the pilots, the aircraft need to fly in U-space. Everything from an objective point of view based on the regulation, and just to put the reader into situation before entering in the part that is more subjective, that is based in our experience, in the experience of the collaborators of this document. So in this part, we collected more than 70 lessons learned and more than 70 recommendations regarding different topics: services, system, aerospace risk assessment, how to coordinate with authorities. So here we try to put all our experience together, not only the technical experience, but also the bureaucratic experience, how to deal with the authorities, what is the process that we have to follow. And I have to say that I'm happy to see that some of the questions that appear in the slide are responded here, or at least we have inputs and lessons learned about these topics. So I will be happy if you can read this document after once it's published. And then we have this lesson learned and recommendation that are quite concise regarding different topics, but also we have 6 different technical appendices where we talk about deployment solution, this key topic like dynamic aerospace reconfiguration, e-conspicuity, integration of the network ID data, how the different projects, BURDI, ÉALÚ-AER, and U-ELCOME did it. Also about architecture, about transition to U-space operation, what happened once a U-space aerospace is designated, how to move from this to real operation. Coordination mechanism, so here the idea was to give more details about the topic and not just stop in this lesson learned or recommendation, but really provide details about the topics. So yeah, this is the document. As I said before, it will be available in the next weeks. And yeah, I invite all of you to read it. And of course, it's an initial document. It's based on our experience, initial implementers. So personally, I will be happy if this is just a first version of a document that can evolve with time and collect the experience of future implementers. And now going into the technical discussion, because today I didn't want to enter, like to read the document or to open the document, so I just tried to organize this technical discussion, but for you to listen this expert from the project about this experience just here, live. So we will start with this topic, surveillance system to support U-space. If we think about surveillance system, this is a wide concept, so I try to put here these 4 questions in order to contextualize what we are going to talk about. If we talk about surveillance system, we talk about technologies, infrastructure that monitor, detect, identify both manned and unmanned aircraft. Why these surveillance systems are important is because they improve situational awareness, they provide redundancy, safety, and security. Where these surveillance systems are expected? Well, in any aerospace, but in our case, we will be focusing in U-space, aerospace, and the surrounding also of critical infrastructure, and how this detection is done with different technologies, ADS-B in antennas, passive radio frequency antenna with electro-optical cameras. So there are different ways of do that. So to talk about this topic, I would like to start with a question. Well, first I'm going to present the expert that will be participating in this session. That is Javier Camacho, sitting just here. That is a UTM UAS research principal engineers in Collins Aerospace. Richard Bellier, that he just presented before. Hello, Richard. That is UTM program manager in Thales, and Jean-Pierre de Muit, that is head of regulatory affairs in Skadron. So I would like to open the panel with a question: why is surveillance essential for U-space safety? Of course, this we will try to focus these sessions in lesson learned and also challenges that are ahead. So, Javier, if you want to open the panel.
Thank you for the introduction. So, in Collins, we see the detect and avoid requirement is a requirement that we've required for all the aerospace users, and not only for manned aviation, but also for the U-space. And because in any case, there could happen any kind of malicious failure to the equipage that these aircrafts are carrying, in case, for example, the DSD. So an accident between an unmanned aircraft might even be a setback for the industry as a whole. No? So we see this requirement that we require this kind of surveillance system. So the only way to allow for safe scaling of the US operation, in this case, is that we are ensuring that both manned and also unmanned systems in the airspace we are aware of that traffic. No? So in a nutshell, we have the requirements to have a situational awareness that is provided to all U-space stakeholders. And in this case, we may think, okay, maybe we are overreacting with some areas. Maybe the surveillance system might be required. Other areas might not be required. From our experience, there might be cases that are presenting, for example, low risk, and with sources such as network remote ID, ADSB, or any kind of other inconspicuity, it should be sufficient. That's right. But for other cases, and we are talking in more complex scenarios, or where the risks are higher, and we are expecting to operate very close to manned aviation in a regular basis, we see that the global requirement that the NSPs are demanding in this case is having a redundancy in these surveillance systems, let's say an extra layer or an extra a safety net, especially for those levels in the very low level. No? So we can always assume that the traffic will be cooperative, but might be not always the case, and we have to be prepared for that case. No? So in the case of ÉALÚ-AER, for example, we deployed a three-dimensional electronic scan AESA radar. In this case, it's a particular system from Collins, which is called Skyler. And we believe this system is required to maintain the routine, safe BVLOS operations of UAS in different aerospaces, but, as you were very well told, but especially in Class G aerospace, U-space. No? We know that the conspicuity only works when aircraft are conspicuous, and there could be a reason that, as I mentioned, that maybe those aircraft could be not conspicuous, you know, and we have to prevent those possible collisions.
On my side, I want just to come back on what is the surveillance, and I have a long experience with the ATC background, and I think we have to refer to ATC. In ATC, we have the different class alpha until Gulf, and we have different type of surveillance. What is a challenge for U-space now is we can have U-space on top of these different class, and we need to adapt the surveillance link to these different ATC or ATM classes. We need really to focus on the collaborative traffic. I agree with you to say that non-cooperative, which are not perhaps defense or which are not an attack, I can say, because that is the difference I can say with ATM. But in our U-space environment, we can have this kind of different people or drones which are non-attacking, unattacking ones. But I think for the U-space part, we need to focus on the collaborative part and adapting with the different technology you mentioned, the surveillance we need to put in place.
Yes, well, good afternoon, everybody. I don't want to repeat too much on what has been said, obviously, but is surveillance essential for U-space? I would say it's one of the cornerstones, if not the cornerstone. I'm not going to refer too much to ATC in this drone environment, but indeed, what see and avoid is for VFR traffic is basically what U-space is in terms of detect and avoid. Is everybody knows where everybody else is, so that's how we make things safe from a tactical point of view. Is the key cornerstone of U-space. It has already been mentioned, I think. It's U-space by definition is a cooperative system. We kind of assume that everybody will comply with the regulations on the 664. So if you take off with your drone in U-space, you have to choose a USSP. But what if you don't? And that's I think, we'll probably come back to it, but in terms of cooperative and non-cooperative, what we try to do in the BURDI ConOps 2 is also make a clear distinction between what is cooperative from a surveillance point of view. I'm referring to the 947, for example, direct remote ID. Network remote ID is cooperative. When your drone has direct remote ID, you're cooperative in a sense that you're letting everybody know where you are. Are you by definition U-space cooperative? No. If you're not a customer of a USSP, even though you're sending out your location details, you're not participating in U-space, hence you're a danger. So I think we need to always make a distinction between cooperative in a sense of surveillance and then non-cooperative in the sense of participating in U-space, yes or no. And the next question then, of course, is, we'll come back to it later, most probably, when thinking about non-cooperative, you have the clueless, the careless, and the criminals. I'm not going to refer too much to that classification, but one of the key questions, of course, is what are the roles and responsibilities of a USSP in terms of non-cooperative detection? Radars cost a lot of money, drone radars cost a lot of money. Is it an obligation of a USSP to detect non-cooperative drones? The answer to that is no. The 664 is pretty clear. You have to take into account non-cooperative traffic when you activate a flight authorization from a USSP perspective.